Hey there. It is time for a new unit. So today is day one of our new unit on data and statistics. And so our goal today is just to become more familiar with the words that are used in data and statistics and what those mean, and take a look at them at a little bit of a deeper level in some real world situations. So in data and statistics, we're talking about numbers. And numbers can be used in lots of different ways. They can be manipulated to present lots of different points of view. So if I am a manufacturer of a particular product, I can use data and statistics to make it seem like my product is a really awesome thing. Or if I'm a competitor of somebody's company, I can use data and statistics to make it seem like their product is not a very good thing. And so whenever we're looking at surveys or percentages or data, we always need to really be thinking about what it's telling us. Think about things like who created the survey? Who collected the data? Who's presenting this information to me? What is their agenda? What is it they're wanting me to believe? Is it fair? Is it unbiased? Is it a good sample? There are lots of questions for us to ask as we take a look at surveys. And so one of the first things that we're going to talk about is a sample. So when we are creating a sample, so if you grab your notebooks and take a couple of notes in some of these vocabulary words. So the first one is sample. And so when I am creating a sample or when I'm looking for a sample of a population, I want it to be just a smaller piece of a larger population. So population is the large group. And a sample is just a piece of that group. And I'm going to use that sample to make a prediction. So, for example, if I want to know, what is the favorite candy of students at Westfield High School, I can't really ask every single student at Westfield High School. So I need a sample of the population. I need a small piece of the population. And we have to look at, is that sample random or not random? Is it random or not random? So that's the next thing to make a note of in your notes is random and not random. If it is random, it means that every single person in that population has an equal chance of being chosen. Random again means that each person in that population has an equal chance of being chosen. Non-random obviously means that each person doesn't have a fair chance of being chosen. So for example, if I want to do a survey of, let's say, how students get to school at Westfield High School, and I stand at the front doors as students are getting off of the bus, and I ask the students that are coming in the front doors, is that a random sample? No, right? Because chances are the majority of the people that I asked that are coming in through the doors right off the buses probably got here by riding the bus. So it's not a random sample. If I want to know if people like Mexican food, and I only ask people who are sitting at a Mexican restaurant, that is not a random sample. So I need to, each person in the population needs to have an equal part of being able to be represented. If I'm doing a survey, for example, of let's say an observational survey, and we'll talk more about those in a second. If I'm doing an observational survey of um, hair color of students at Westfield High School, and I sit outside the green hallway and I watch as people walk by, I just tally how many people I see with blonde hair and black hair and brown hair and red hair. And I just tally and I sit right outside the green wing here by the math department down here. Is that a random sample? No, it's not because I'm not including the people who never come down to this building who don't have math this trimester. They don't have an equal chance of being part of the observational survey that I'm doing. So a random sample needs to include all of the different people. So um, what makes it a good sample or a bad sample? A good sample doesn't have to be random. It just needs to ask a number of enough people. So if I ask, a good sample will have, if I'm looking at, there's 1,000 people in my population that I'm looking at, and I only ask 10 people, that's not a very good sample. I need to ask the larger number of people that I ask, the better quality that my sample is going to be. If I want to know the opinions of 1,000 people and I ask 250 people, chances are that I'm going to be able to predict or make an inference about my data a lot better. If there's 1,000 people and I only ask 50, my data is not going to be very accurate. I'm not going to be able to use that to make predictions as much. So samples need to be random or non-random. Understand that. What makes a good sample or a bad sample? And we know if there's bias in there or not. And bias is more when we're creating questions. So we'll talk more about this. We're going to talk about bias and inferences. All right. So let's take a look at these examples on the screen right here. And the first one says a beverage company wanted to see if people in the United States liked their new logo. A beverage company wanted to see if people in the United States liked their new logo. So which choice best represents population? So population, member is the larger group. So would the population be a selection of logo artists, or every person in the United States, or a selection of shoppers from different states, or 3,800 children ages 5 to 15? So in this case, the population, the larger group, is going to be B, every person in the United States. Now, if this question asks for a sample would be a selection of shoppers from different states, would be the sample of it. Look at number 2. A musician wanted to see what people who bought his last album thought about the songs. Which choice best represents a sample? So now we want just the smaller part of the larger group. So sample, would we ask every person who bought the album? A selection of people who didn't want to buy the album? 250 girls who bought the album? Or a selection of 3,294 people who bought the album? So if we want to know what people thought about his album, we wouldn't ask every single person who bought the album, right? So we would do a selection of the people. So the answer would be D. So the population would be everyone who bought the album, and a sample would be D. Now, let's take a minute and add to our notes the word bias, B-I-A-S, bias, B-I-A-S. Bias means that we're intentionally or unintentionally skewing the data in a particular direction. Maybe we're wanting the data to say something, or maybe we don't even realize that we're doing it. Like I said, it doesn't always have to be intentional, but it's how we create a survey, how we ask questions, how we do this sample can create bias in a survey. So for example, for this one, if we asked only people who didn't want to buy the album what they thought of the album, that would be bias, because that group is going to have a definite opinion different than the whole group for sure. Or if we asked only the girls and we didn't ask the boys, well, maybe the songs on the album tend to be kind of more songs that girls would relate to and would like. And so it's going to skew the data from the results. We have to be really careful of bias when we're creating samples. Like I said, it can be intentional or unintentional. You know, for example, you could be dressed all in IU gear from head to toe and have an IU hat and IU sweatshirt and, you know, have things, maybe wearing IU shoes or whatever. And you're doing a survey about what college is people's favorite college. You know, what is their favorite Indiana college? And if what you're wearing has something on it that can create bias, and it may not even be intentional that you're doing it, or it may be intentional that you're doing it. It could be either way. But we definitely want to avoid bias where we can. All right, let's look at another example that's on here. So erase those. Let's move this down. Let's look at number 4. Number 4, before a nationwide election, a polling place was trying to see who would win. So which choice best represents a sample? So just a piece of it. So it's a nationwide election, and they're trying to figure out, this is what they did exactly right. The election's going on, is they're trying to predict the presidential election and the Senate and the House of Representatives. They're trying to predict those. So this is exactly what they do. Is the sample, would it be a selection of voters over age 50? No, because that would be biased. A selection of male voters? That would be biased. A selection of voters of different ages, that'd be a sample. That would be a good sample as long as they had enough people that they asked. If it's a nationwide election and you only ask 1,000 people, it's not going to be a good sample. So you need voters of different ages, voters from different states. You need a large enough pool of people for it to be a really good sample. And we're certainly not going to ask all voters. All voters would be the population. All right, let's look at number 6. Let's skip number 5 and look at number 6. Amir wanted to see if the people in his town thought he was doing a good job. So who would he ask? What's a sample? Would he ask 1,000 unemployed voters? That would be biased, right? If you're asking unemployed people what kind of a job the mayor is doing, they're probably not going to say very favorable things. Would you ask the mayor's family? No, bias there is again as well. Plus, it's a very small sample. The residents of the town, that's the population, not the sample. 242 voters would be the sample. As long as those 242 voters were random ages, random income levels, random genders, you know, and you try to have a good representation of who the people in the town really were. I get the idea how it works? All right, let's look at just 2 more and we'll be done. Let's look at number 2 on this page. So number 2, a restaurant chain wanted to find out how a customer experience was in the store. Which choice best represents a sample? They want to know what their experience is like in the store. So they ask 1 out of every 35 customers. They ask all of the people who wait at the store, right? You can't do that. That's way too many people. It's population. 240 customers who spent more than $10. 299 customers who filled out complaint cards. They filled out complaint cards. They're probably going to give things that's biased. So do you think it's all of this? Do you think it's 1 out of every 35 customers or 240 customers who spent more than $10? Which one do you think? 1 out of every 35 customers in saying that they bought something would probably be the more random one. Although looking at customers who spent more than $10, that could be a good one as well too. But the best answer here, I would say, is A. But I could see that you could argue for C as well too. I think both are good options, but one gives you more of that randomness of just like every 35 people, you pick one. So it's just a random person that we don't know how much they spent. Whereas customers who spent more than $10 probably are going to be more positive just because they're spending more money there. So I would go with A. All right, and the last one to look at is down here in the bottom, number 5. A school principal wants to see which subject the 845 students in his school liked best. So would he ask students in 3rd grade? No, because that's skewed, right? That's a skewed bias. The first 77 students who come into school, the students making a B in math, or all the students in the school. Well, all the students is the population, so it's not that. Students making a B in math, that's going to, if you're saying what's your favorite subject, and students are doing well in math, then they might pick math. Of course they'll pick math, right? Everybody loves math, at least math with me. Anyways, and so the correct answer would be the first 77 students who come into school, they'll give him that random story that he's looking for. All right. Then below, a couple other things we're looking at. Again, samples, random, non-random, good sample, bad sample, is there bias? And then from that, we want to make inferences. We want to make predictions. That's why we're doing surveys. That's why we're doing the sample and collecting the data, is because we want to use that data that we have to make predictions about other groups and other populations. So if we predict that, if we collect the data and we look at and we say 33% of the students at Westfield High School like whatever. They like whatever. They like, this was their favorite TikTok video or their favorite whatever. Could we use that information? Could we then say, okay, well, if 35% of students at Westfield like whatever, does that mean that 35% of the students at Westfield or at Noblesville High School would like the same thing? Chances are probably yes, because the populations are very, very similar. But if we said, is it true that 35% of the students at a school in, say, like California and like San Diego, California would like the same thing? Probably not, because they're 2 different populations. So we can take the percentage and apply it to a population that's similar, but we can't apply it to a population that's not the same. He said this unit, it's just a short unit. It's going to have a lot more vocabulary, a lot more words, which is it's not a lot of numbers, this one. There'll be some numbers in some lessons we do, but more just kind of the concepts of it. All right, last things to look at. We have Latrice wants to determine what the favorite sport is among all the students in her school. The problem, there's 850 students enrolled, so she won't have time or ability to survey each and every student in her school. So what are some ways that she could carry out the survey? Now in class, we have a great conversation about this. A little harder to do in this format, so I want you to think about that. What could she do? And there are lots of ways to do surveys. She could ask the first people to come in each of the doors. You have somebody stand at each door, people come in and ask the first 25 people. She could ask a random number of people at each of the different lunches. She could randomly select, use a random number generator and select random student numbers and send them an email to participate in a survey. We've been doing in our core classes some of the surveys in there. So you may have seen some QR codes or things for surveys that some students are working on in their senior AP statistics projects that they're doing. So you do a QR code, put it in the hallway and randomly ask people. It could give you that random ability. So lots of ways that she could do it. If she doesn't get a response from every single student, do you think her survey is accurate? If we talked about, yes, it could be, as long as it's random and a large enough sample. If there's 1,000 students in the school and she only gets 10 responses, it's not going to be very accurate. But the larger the sample, the more accurate that her statistics will be. Can she survey just the students in one grade level? No, not really. Or ask only the students who play sports? No, that creates bias. So just focusing on one specific group, only focusing on math students or only focusing on freshmen or only focusing on athletes, it's going to create biases on there. All right. And this one, I think we're all set. So we would talk about this if we were in class, but we're not in class. So we'll go ahead and skip this part for now. All right. So go ahead and take a look at the Canvas quiz and answer the questions there. And I will see you again in class or online again soon.